Good morning and welcome back to the History and Philosophy of Science in 6 Easy Steps. This is your Week 4 recap and Week 5 preview. That's right, we just have 2 more weeks left. Okay, so let's start with a little recap of last week. Last week we focused in on what's called the scientific revolution. Now this kind of confused some of you, I think, because reading Thomas Kuhn's book, you started to look at the term revolution, scientific revolution, in a very precise and different kind of a way. And this idea of one big scientific revolution probably didn't make a whole lot of sense to you at this point when you tried to fit it in with some of what you've been learning. But let's delve into that a little bit. So first of all, what is called the scientific revolution by historians of science, of course, started, well, typically assumed to have started around the Renaissance, going up into maybe the 1700s, something like that, characterized by people like Copernicus and Galileo up through Newton. There were some medical discoveries, all kinds of stuff happening in those times, particularly around the 15 and 1600s is when a lot of that really started to move quickly, right? So I just want to make a couple of points about it. A few of you brought out that one way to look at it is that there were a whole series of paradigm shifts, a whole kind of an explosion of paradigm shifts, if you will, and that's how you related it to Thomas Kuhn. And I think that's an excellent way to look at it. That is definitely one way to look at it, that this was an explosion of paradigm shifts. Speaking of explosions, when did this happen? At least one of you pointed out that this was happening toward what we would call the knee of the exponential curve that you drew in your first week with your graphs. This period was just at the beginning of the real exponential part of that thing. The explosion in growth of scientific knowledge really happened at that point. Or maybe not scientific knowledge, maybe we shouldn't say it that way, but the number of discoveries, right? The number of new things that were being recorded about the world. So we could look at it as a kind of explosion in paradigm shifts. But there's another kind of way to look at it that some of you kind of hinted at when you related it to Karl Popper, because you said that a lot of these things had to do with a shift in thinking toward the critical attitude away from dogma. And so really you can look at the scientific revolution as the formation of science in the Popperian sense, I guess we could say. The formation of a whole bunch of new true sciences, a shift from pseudoscience to science, a shift. I wonder if we could say that the scientific revolution was one gigantic paradigm shift from pseudoscience to science in the Popperian sense. So was it a giant paradigm shift from people viewing the world one way to what we might call the scientific worldview on the other side of that shift? Now, one problem with that one of you pointed out, was it's not as if everybody shifted all at once. That's true, but it never is it? Remember what Kuhn was talking about in his book about how paradigm shifts every time, even if it's just a relatively narrow field, it happens maybe with one or a few people at first, and then gradually more and more people come on board, more and more people are converted to this new way of seeing the world, and some are never converted. So what if the so-called scientific revolution still hasn't happened for some people? Is that a possibility? Interesting to think about. So good job on those. Some of you will probably want to be doing some revisions on those just because you didn't provide enough specific evidence maybe, or didn't show me that you definitely understood how Popper would apply, and so on. So take a look back at those, if you will. Okay, secondly, we looked at the so-called European miracle. So this thing called the scientific revolution happened first in Europe. And the question is why. And so this was first termed the European miracle by an author some years back who was dealing with this issue. And there's been a lot of discussion about it. One of the most famous recent treatments of it was by Jared Diamond in his book Guns, Germs, and Steel, where he looked at kind of the reasons for Eurasian prominence, and he also dealt with European prominence in that book as well. So first of all, there's a couple things I wanted to bring out here about this. And the first is that, and I think one of you might have brought this out in your paper. One is kind of simple possibility that I don't think was really brought out by either of the authors that we looked at, is that if we think about the exponential curve, if just by chance one area, one culture, for example, was a little bit further along on that curve than the others, then that could make a huge difference if you're around that knee portion of the curve. So let's say that just by chance, just by pure chance, the European culture was a little bit further along on that exponential curve to where it started to go up fast. That would make a huge difference over a period of a few hundred years, wouldn't it? So is there the possibility that it's just chance? Maybe. I don't know. Okay, at this point I'm going to switch over to the video that I made last year because I think I'm not sure I could say it any better in terms of explaining and going into kind of a summary of the European miracle portion of our assignment for this week. So let's switch over to that, and then I'll talk to you again at the end of that. I just want to take a look at the graph, because if we look at the graph that we produced week 1, we get a pretty good idea here. This thing just took off like a rocket basically sometime between 1500 and 1600. That's when it really started to, the rate started to double every year or more, and we got this real explosion. So we're going to place it probably in the 1500s. And the question of where is actually pretty easy to solve, because if we look at what was happening in science during those times, we're going to pick out, in particular, Copernicus being in the mid-1500s, and another scientist named Vesalius, who was involved in anatomy and physiology. And it turns out that both of those scientists were involved in the same university, which was located in Italy. And the city in Italy where they were located is called Padua. And we've got a nice little picture of it here. This is kind of a historical picture of that city. And so this is in the middle 1500s. And so we can really locate the beginning of the scientific revolution in a very particular place in Europe and even in northern Italy. Okay, it was actually under the control of Venice, I believe, at that time. So we've got the when, we've got the where. By the way, this same university was also, there was a couple other very influential scientists. Galileo was involved there. William Harvey, who kind of elucidated the circulation of the blood, he was involved there as well. So very influential place, key place in this whole history of science exploration. Okay, so the big question though is why? Why did it happen there and then? Now, I hope that you watched the full video about Jared Diamond's book. His book is a very interesting read, by the way, also, so I'd encourage you to get it, Guns, Germs, and Steel, and take a look at it, especially if you're into history. And basically, he's focusing on the question of why did Eurasia pull ahead of the rest of the world, and he points out a couple of interesting things. One is geographically, because it's east to west, oriented east to west, that it was easier for trade to happen because the climate was all the same pretty much along there, and so the crops and everything that were developed could be traded and used all across that continent pretty much. The other thing that he talks about is the fact that there were easily domesticable species in all the areas where big civilizations grew up, and that Asia and Eurasia had more than their share of these sorts of species. And so this gave them through agriculture gave them a big boost. See, what agriculture does is it basically makes it much easier to feed the population. And so it starts to free up a lot of time. And we'll get to that in a little bit more detail in a second. The importance of trade, by the way, is very interesting, and this is brought up by a scientist by the name of Matt Ridley, who wrote a book called The Rational Optimist, and he focuses on this concept of trade as being kind of the key piece in the development of civilization as a whole and modern civilization. That when people trade, when they exchange goods and ideas. And that these ideas, well, he talks about ideas having sex. It's kind of like a recombination of ideas that makes new ideas. And so this kind of grows exponentially, as we'll be getting into a lot in your final week, in week 6 of this course. Now, but why Europe? As I said, most of Diamond's theories kind of explain Eurasia's prominence, but don't necessarily differentiate between Europe and other parts of Eurasia, such as India and China, and the Middle East and the Fertile Crescent itself, for example, which was the origin of wheat, which is the key in modern agriculture. He does mention it a little bit, and especially if you read the summary on Wikipedia, he talks about the effect of what he calls the Balkanization in Europe. If you look at this map even, you notice that China, for example, is an enormous country. India, very large country. In Europe, the countries are still divided into small pieces, and basically the geography there, and it shows up pretty good in this little map right here, there's a lot of geographical barriers in Europe that break it into small countries. And what effect that has is that because you have these separate political entities, that it creates kind of a competitive effect between them, and they compete for people, basically. So merchants, for example, could move from one country to another if they thought that the policies there and stuff were better. And so this kind of leads to sort of a Darwinian survival of the fittest between the countries, and leads to improvement in their social, political, technological features, I guess you could say. But to really more fully answer this question of why the scientific revolution happened where and when it did, I think we need to work backwards, okay? And I'm going to refer to the article, the Singh article as well, but what I want to do is start with what is science. So I think you have a pretty good idea from reading Popper and Kuhn and looking at the history of science so far that it involves a couple of things. One is, I guess you could probably boil it down to this, that the idea of science is that you can look at the world, the physical world, and you can develop hypotheses and theories for how it works, how it always works, and then you can test those theories by making measurements. Okay. Now I think that's a pretty defensible view, according to Popper and Kuhn, and that they would both probably agree with that. So if we define it like that, then we can ask the question of what foundation was necessary for that enterprise of science, for that kind of way of doing things to really take off. And I think we can come up with a few things. One is that you have to believe that the world works the same way all the time. So this concept of an orderly universe is very important. And this is where worldview and religion possibly comes into play. Some historians of science have said that one of the things that made Europe take off and separate from the rest of the world technologically, scientifically, was the monotheistic belief that Christianity carried with it, which basically said that God had created an orderly universe that worked like clockwork. Judaism and Islam also have a similar worldview, by the way, but many of the other countries didn't. Even the ancient Greeks, at least the religious Greeks, basically they looked at it like this. You never knew when a god was going to just kind of get upset at you and do something just random, or maybe you got struck by some god's arrow and that's why you fell in love with somebody. and so on. So a lot of these other countries didn't have that kind of worldview that fostered that. But in any case, you need that. You need a belief in an orderly universe, that everything's not just willy-nilly, that it's not just going to totally change tomorrow. Rocks aren't going to start falling up tomorrow, that sort of thing. So that's the first thing. The other is you need this view of human reason and skepticism. So you have to believe in the competence of human reason to figure the world out. I found a really cool quote. I haven't really verified it, but it was from Leonardo da Vinci, which, by the way, was from Florence, Italy, in the late 1400s and early 1500s. And he says this: if you find in your own experience that something is a fact and it contradicts what some authority has written down, then you must abandon the authority and base your reasoning on your own findings. This, by the way, is very similar to some of the things that Francis Bacon said in the 1600s in England about being skeptical and looking at the world for evidence, for facts, and to figure things out, and to question authority and to question dogmas. So you need this kind of boldness to question dogmas, all right? And I think maybe that's making me think right now of the Reformation and Martin Luther and his contributions in challenging the authority of the Roman Catholic Church. Okay, another thing that you need is you need free time and free money. So you need, not free money, but plenty of money if you're going to have time to do experiments and stuff like this, you need to be fairly prosperous. So what you need is a society where there are prosperous individuals who can spend their time doing this sort of thing. And we could add to that and kind of pull in the Singh article here. You need prosperous individuals who are also skilled, in many cases skilled craftsmen, so that they can work these instruments and do these experiments, okay? And they have to be educated. So there's a lot of things coming into play. You need this prosperity. Now, to get this kind of prosperity, you're going to need trade, right? You're going to need a certain amount of economic freedom, and you're going to need technology, okay? So also, technology also plays into the need for precision measurement. So if you can't measure things precisely enough, it's going to be very difficult to test your hypotheses. If you can't measure time well enough, it's going to be hard to measure the speed of a rolling cannonball or something like that. So we need precision technology. And this kind of gets into our question for next week, but we'll get to that later. Excuse me, little kombucha break. Just got into this stuff, fermented green tea. Pretty good stuff. So, as I was saying, we need a few things to build the foundation for modern science. We need a belief in order. We need a belief in human reason and kind of a skepticism of authority, a willingness to question dogma. We need free time, free money, plenty of trade, prosperity, and technology. Okay, we need some technology to build our instruments and to free up time. One of the things that technology does is frees up time. It gives us more leisure time. Gives us a lot more leisure time. That's one thing we definitely have a lot more of. Interesting thing about free time. This book is by a guy named Peter Diamandis, one of the founders of the X Prize, I believe, and he wrote this book called Abundance. The Future is Better Than You Think. And he's got this quote in here. He's talking about lighting and how technology changes over time and really frees up time is what it does. Today, light will cost less than half a second of your working time if you are on the average wage. A half a second of work for an hour of light. So he's talking about the cost in terms of like your labor, right? How much you'd have to work to pay for something. So half a second of work will buy you an hour of light today. Had you been using a kerosene lamp in the 1880s, you would have had to work for 15 minutes to get the same amount of light. A tallow candle in the 1800s, over 6 hours work. And to get that much light from a sesame oil lamp in Babylon in 1750 BC would have cost you more than 50 hours of work. think about what that means. That extra free time that started to open up was tremendously powerful, and it still is. Okay, so did Europe meet these criteria in that time period, say the 1500s? Well, for one thing, religion, they were dominated by Christianity, which was monotheistic and had this belief in an orderly universe. God kind of setting things in motion, or at least presiding over things in a regular and orderly way, and humans having a sort of independence. Those were, I think, some of the beliefs that are characteristic of that worldview. And also we have this Balkanization effect that we talked about before, which would lead to possibly competition between these different states, which would increase, possibly increase prosperity and technology, as we mentioned before. Okay. Oh, by the way, and both of these things could also lead to the skepticism. Now, it seems kind of weird to say that religion could lead to skepticism, but if you've got a religion that actually is kind of individualistic, which Christianity is, then it kind of encourages reason, then apparently, at least, that's kind of what happened, isn't it? I mean, Martin Luther himself was led by his own faith to question the dogma of the Catholic Church. So I think we have those criteria in Europe, and I guess, I mean, we could talk about whether or not those criteria were met in India and China, for example, and the Middle East, and why they were or weren't. And some of that is picked up in the Singh article, and I've already mentioned some, particularly with respect to the geography of Europe and it being divided into small states. Even northern Italy at the time we're talking about, like in the Renaissance and into 15 and 1600s, was divided into small, what they called city-states. And this kind of supports the same hypothesis, that this competition between these smaller countries, the competition for people, for intellectual capital, for economic competition, that sort of thing. By the way, just to mention also another effect, a kind of geographical effect, is when you have a really large country or empire, for example, and this was true about the Roman Empire as well, you don't get this kind of effect of competition because the people can't leave. They're basically trapped in that empire, under that authority. If you were living in the middle of the Roman Empire at its height, you really couldn't get out. I mean, there weren't any alternatives. I mean, you might have to travel 1,000 miles just to get to the border, and then they might not let you out. I mean, and some of the same thing in the Eastern empires. So in China, for example, is very large. You can't just walk out and go to the next country and decide to live there. So it was much easier in Europe for people to do that. People were much more mobile. And many historians, I think, have pointed out this sort of effect. By the way, as the article pointed out, there does seem to be a strong relationship between trade and kind of the merchant class and the scientific revolution. For example, even Copernicus himself was involved in finance before he developed his heliocentric theory, or while he was doing that. So these people had reason to be very careful about measurement and about numbers. And the same was true, interestingly enough, about Lavoisier, who was a tax collector, a very precise person, and led him to really question things like the gain of mass by metals when they're burned, for example. Right. Now, this whole theory, though, I wonder, is this theory, and we could, I don't know if I should even call it a theory, it's not a unified theory. Let's say Diamond's approach, Diamond's hypothesis of how this all happened. Is this scientific, according to Popper? Is it falsifiable? Could we make some specific predictions? Interesting. You know, it actually has been tested. One way they've tested it is scientists have looked at the genetics of populations, because they've said, if Diamond's hypothesis is true, then we should see human migratory patterns that are mostly east-west in Eurasia and north-south in the Americas and in Africa. And they've actually tested this and verified it. So there are ways, and I think a lot of times with some of these, what we might call more sociological theories or anthropological theories are actually testable, and I would add even educational theories into that. So some of what we might call the social sciences or the soft sciences, a lot of these are testable. Psychology, right? A lot of these are testable if we just get creative with ways, with things that we can measure and making specific predictions. So tying that back into Popper there for you. All right, looking ahead to week 5. Last week, week 4 was really about the effect of society on science. How does society form science? How did it form kind of the cradle or the nursery of science? How was science nurtured within society? Now we're going to be looking at the opposite. We're going to look at the effects of science on society, the benefits and possibly otherwise. So we're going to start with differentiating between science and technology, because we've kind of allowed those to be the same thing up till now, but I want to make a distinction at this point, a clear distinction. And I want you to answer the question in the first assignment. What's the relationship between science and technology? And I've provided an article for you that's very specific with some great examples. It gives one viewpoint on this that you can use as one of your references, that you should use as one of your references in your papers. Basically, you're asking which came first, science or technology, or which comes first. Kind of rings a bell from some things Popper was talking about, right? Which came first, the chicken or the egg, he mentioned. Which comes first, hypothesis or refutation, right? That sort of thing. So anyway, let's do that for our first assignment. And then for the second, we're going to be listening to an abridged version of a book by the famous scientist Carl Sagan, who authored the Cosmos series. And his book is called A Demon-Haunted World. Science is a Candle in the Dark. And what it's about is the scientific worldview. So it's going to broaden us a little bit, and we're going to be looking at science and its technological implications. And then in the second essay, you're going to be reflecting on Popper's book, which is about the impact of science on the way we think about the world, the way we look at the world. Okay? So that is going to be what I call reflection. That means that I'm not giving you a specific question to answer. I'm just asking you to reflect on it. But I do want you to develop a thesis, a clear thesis for your reflection, some point that you're going to be trying to make, or a couple of points or a few points. All right? And then use examples from Sagan's book. Okay, so that's what we're doing for the second one. Now, next week, we are going to be finishing off the course with a look into the future. We're going to be looking at the work of a famous inventor named Ray Kurzweil, and a futurist, and he's made lots of predictions about the future, one of which he calls the singularity. Okay, so that's what we're going to be doing in the final week. Just a reminder to do your Twitter chats. Make sure you do that. Those are due tonight and every Sunday night. And make sure you reply to one other person on those. So look up Q for the questions for this week. You'll see up there. I also posted the questions themselves this time on the stream at your Google Classroom. Okay, and once more, you've still got plenty of time to do revisions on your old assignments, and in a lot of cases, they're just little things. For example, not having citations throws you into level 3 instead of level 5 on your rubric for one of those criteria, right? So there's easy ways to make these revisions. It does help if you send me a note that says I made some revisions to this. That way I know to look for it. Okay, but you can do that, but all of your work is due August 15th. Okay, if for some reason you can't complete it all, including the revisions, by the 15th, please contact me. But that's what I'm expecting at this point. Okay, so good luck with that, and I hope you enjoy this week and Carl Sagan's book and looking at science and technology in a little bit more depth.